Good morning, children. In the last module, we discussed about the properties of a parallelogram, children. We learned the 9 properties. One is, in a parallelogram, diagonal divides it into two congruent triangles. Second one is, in a parallelogram, opposite sides are equal and its converse is also true. And third property is, in a quadrilateral, if opposite sides are equal, then the quadrilateral is called a parallelogram. Same like that, angles also. In a parallelogram, opposite angles are equal, and in a parallelogram, diagonals are bisect each other. Okay, these all properties we learn in the last module, children. Yes, now today we are going to discuss about the last content in this chapter, that is midpoint theorem. Yes, first suppose one triangle is there here. In triangle ABC, D is a point on the AB and E is a point on the AC, such that is given AD is equal to 2 centimeters, BD is equal to 2 centimeters, AE is equal to 3 centimeters, EC is equal to 3 centimeters. That means what? D is the exact midpoint of AB. D is the midpoint of the AB and E is the midpoint of the AC. Yes. So if D is the midpoint of the AB and E is the midpoint of the AC, if we join these 2 points, DE is the line segment is parallel to the third side BC. Means if D is the midpoint and E is the midpoint of AB and AC respectively, then DE is parallel to BC. That is only the midpoint theorem, children. Midpoint theorem states that a line segment drawn through the midpoints of any two sides of a triangle is parallel to the third side and also off of the third side. The statement is, a line segment joining the midpoints of any two sides of a triangle is parallel to third side. A line segment joining the midpoints of any two sides of a triangle is parallel to third side. Here you should underline the points. Midpoints of any two sides of a triangle is parallel to third side and also off of the third side. Okay. Yes. Consider the triangle ABC now. ABC. In this triangle, D and E are the midpoints of AB and AC respectively. First write the given. That is, in triangle ABC, D is the midpoint of AB and E is the midpoint of AC. That means D comma E are midpoints of AB comma AC respectively. D comma E are midpoints of AB comma AC respectively. Then you should join this D and E points. You get the line segment. You should prove that DE is parallel to BC and DE is equal to half of the BC. So see here first. To prove this one, we require the construction. See the construction. That construction is draw a line parallel to BA through C. Draw a line parallel to BA through C. It meets DE produced at F. It meets DE produced at F. Simple question, Nana. Listen carefully. Draw a line parallel to BA through C. It meets DE produced at F. DE produced at F, Nana. Yes, that is draw a line parallel to BA through C. It meets DE produced at F. That is the construction. Okay, now see the figure everyone carefully. First is given D is the midpoint of AB. That means these two parts are equal. Yes. Next one, E is the midpoint of AC. That means AE and EC both are equal. Okay, that is given. What is our RTP? You have to prove the DE is parallel to BC. DE is parallel to BC. For that one, I want to prove BCFD is a parallelogram. I want to prove BCFD is a parallelogram. If BCFD is a parallelogram, then DF is parallel to BC and DE is parallel to BC. Yes. To prove the BCFD is a parallelogram, just I am revising one theorem, that is last theorem. In a quadrilateral, one pair of the opposite sides are parallel and equal. Such a quadrilateral is called a parallelogram. We are using the last property of a parallelogram, that is a quadrilateral in which one pair of the opposite sides are parallel and equal. Such a quadrilateral is called a parallelogram. Simple, Nana. Suppose if BD is equal to CF, already BD and CF both are parallel. If so, both are equal means automatically BCFD is a parallelogram. To prove the BD is equal to CF, I am going to prove these two triangles are congruent to each other. What are that one? This triangle and this triangle. Yes, see the proof, children, everyone. Yes, the proof is, I consider the triangle AED, comma, triangle CEF. I am going to prove these two triangles are congruent. Already in the triangles lesson, we learned the congruencies. We revised them so many times now. Here, these two lines are parallel. Then this angle and this angle are equal. Why? If AC is a transversal, these two angles are equal because alternate interior angles. And already is given these two sides are equal, included side. And these two angles also equal. Why these two angles are equal? Because they are vertically opposite angles. Yes. So angle side angle. Angle side angle means two angles and included side of this triangle are respectively equal to the two angles and included side. Then these two triangles are congruent by ASA congruency. Do you understand, children, how to prove that two triangles are congruent to each other? by ASA congruency. How? By the construction these two are parallel, Nana. If you take AC is a transversal, these two are alternate interior angles. Yes, these two angles are alternate interior. That only I am writing here, Nana. That is angle EAD is equal to angle ECF, alternate interior angles. Next one, AE is equal to CE because of E is the midpoint of AC from the given. Then this AE is equal to CE, it is given. It is given. Next one, angle AED is equal to angle CEF. Angle AED is equal to angle CEF, that is vertically opposite angles. Angle side angle. By ASA congruency, triangle AED is congruent to triangle CEF. If two triangles are congruent, corresponding parts are equal by CPCT. Corresponding parts of the congruent triangles are equal. You should identify what are the correspondings. For AE correspondence is CE. For ED correspondence is EF. And AD correspondence is CF. So that means then AD is equal to CF by CPCT. Already is given D is the midpoint of AB. That means AD is equal to BD. From these two equations, we can write BD is equal to CF and BD is parallel to CF from the construction. Therefore, BCFD is a parallelogram. Yes, clear children? Why it is a parallelogram? Now only we said one pair of the opposite sides are parallel and equal. Such quadrilateral is a parallelogram. Here BD is equal to CF and BD is parallel to CF. That's why BCFD is a parallelogram. In a parallelogram, opposite sides are equal, opposite angles are equal, and opposite sides are parallel also. That's why here, therefore, BC is parallel to DF and BC is parallel to DE also. That is the proof of the midpoint theorem, children. And we can prove that this DE is equal to half of the BC also, Nana. How means? Now only we proved these two triangles are congruent, na? Then this part and this part are equal. Means DF is equal to 2 times of DE. DF means what? BC only, opposite sides of a parallelogram. Therefore, DF is equal to 2 times of BC. DE is equal to half of the BC, Yes, here in a parallelogram, opposite sides also equal. BC is equal to DF, Nana. BC is equal to 2 times of DE. Then DE is equal to half of the BC. That also we can write, children. Okay. But midpoint theorem means you have to take this one only. What is the statement, children? A line segment joining the midpoints of any two sides of a triangle is parallel to third side and also half of the third side. Here I consider the triangle ABC. According to the statement, midpoints of any two sides. So I consider the triangle ABC. D comma E are midpoints of AB and AC. So AD length is equal to BD length, AE length is equal to CE length. Next, then prove that line segment is parallel to third side. Means you have to prove DE is parallel to third side is BC. That is DE is parallel to BC. For this one we require the construction, that is important. Draw a line parallel to BA through C. DE produced at F. It means the DE produced at F. Next one is to prove these two are parallel. I want to prove this one is a parallelogram. For that one, I consider this triangle and this triangle. I proved them as congruent to each other. How means these two angles are equal. If two lines are parallel, this is a transversal. Alternate interior angles. Alternate interior angles. And already is given these two parts are equal side. And these two angles are equal. Why these two angles are equal? Vertically opposite angles are equal. By ASA congruency, both triangles are congruent to each other. If two triangles are congruent, by CPCT, AD is equal to CF. Already is given AD is equal to BD. From these two cases, we can write BD is equal to CF. From the construction, BD is parallel to CF. A quadrilateral in which one pair of the opposite sides are parallel and equal, that quadrilateral is called a parallelogram. So DCFD is a parallelogram. In a parallelogram, opposite sides are parallel. So BC is parallel to DF. So BC is parallel to DE, children. Yes, this is the midpoint theorem. Based on this one, we have so many applications now. Based on this one, we have so many applications. Suppose one simple example I will give. Suppose I am giving one simple example. This is a triangle PQR. This is M, N are the midpoints. M and N are the midpoints of the PQR. And O is a midpoint of QR. One simple example. Yes? Here, listen carefully, is given the dimensions of this PQR triangle. This is 5 centimeters, this is 6 centimeters, this is 7 centimeters. Okay? Is given the PQ length is 5 centimeters, QR length is 6 centimeters, PR length is 7 centimeters. Then what is the perimeter of the triangle MNO? What is the perimeter of the triangle MNO, children? Based on this theorem, MN is parallel to QR and also half of this one. If it is 6 means this is how much? 3. If it is 7 means what is this one? 3.5. If it is 5 means what is this one? 2.5. 2.5 plus 3.5 is 6. 6 plus 3 is equal to 9. Sorry. 6 plus 3 is equal to 9. Like that, we can solve the so many problems, children. And its application will come in the 10th standard triangles chapter also. Nana. It is very, very useful, this theorem, children. Okay. Next, it's a converse. Converse means reverse only, children. Suppose one triangle is there. In this triangle ABC, D is the midpoint of AB. We draw the line through the D. It parallel to the BC. It parallel to the BC. Then it will bisect the AC. Then it will bisect the AC. Means a line segment drawn through the midpoint of a one side parallel to the another side, it bisects the third side. 3 points are there here. First one is we drawn the line segment through the midpoint of one side and parallel to second side. It will bisect the third side. So D is the midpoint of AB. and DE is parallel to BC. Then DE bisects the third side. Third side means what here? That is AC. That means DE bisect AC. We have to prove E is the midpoint of AC. Nana. Simple proof. Nana. Listen carefully, children. Converse of midpoint theorem, that is a line segment drawn through the midpoint of a one side parallel to the another side, it bisects the third side. Okay na? Again I am repeating the statement. A line segment drawn through the midpoint of one side parallel to the another side, it will bisects the third side. Okay, first is given D is midpoint of AB, then AD is equal to BD. Okay, and DE is parallel to BC also is given. DE is parallel to BC also is given. RTP is, we should prove that AE length is equal to EC length. Simple proof, Nana. That is, mark one point F on this BC. That is the midpoint of the BC. Mark one point F on the BC, that is the midpoint of BC, and join D to F. According to the midpoint theorem, DF is parallel to BC, yes? That is, mark midpoint of BC, that is F, and join D to F. By midpoint theorem, DF is parallel to AC, and DF is equal to half of the AC. DF is parallel to AC and DF is equal to half of the AC by midpoint theorem. If DF is parallel to AC means DF is parallel to EC. Already is given DE is parallel to BC. My question is, then DFCE is what kind of quadrilateral? Already is given these two are parallel. According to midpoint theorem, we proved DF is parallel to EC. In a quadrilateral, both pairs of opposite sides are parallel. That quadrilateral we call it as a parallelogram. Yes, DF is parallel to EC and DE is parallel to FC. Therefore, DECF is a parallelogram. In a quadrilateral, both pairs of opposite sides are parallel. Such quadrilateral we call it as a parallelogram. So in a parallelogram, opposite sides are equal, no? Yes, in a parallelogram, opposite sides are equal. That means DF is equal to EC. Already here we written DF is equal to half of AC. DF is equal to half of AC. Yes, and we proved DF is equal to EC. Instead of DF we can write the EC, na? EC is equal to half of AC. That means this is half of AC means remaining half is this only. Therefore, AE is equal to half of AC. AE is equal to EC. This is the proof of the converse of midpoint theorem. Simple proof, Nana. You have to draw DF where F is the midpoint of BC. Then by midpoint theorem, DF is parallel to AC and also half of the AC. Already is given these two are parallel. So this is a parallelogram. Means these two are equal. Already we proved this one is equal to half of this one. Yes. Then AC is equal to 2 times of DF. 2 times of DF means 2 times of EC. Therefore, EC, AE both are equal to each other. This is the converse of midpoint theorem, children. Yes, a line segment drawn through the midpoint of a one side parallel to the another side, it will bisect the third side. This is a converse of midpoint theorem. Yes, children. Based on this one, we can solve the so many problems, children. Okay, especially in this quadrilateral, children, almost all are the theorems, Nana. Complete we discussed almost 11 theorems, children. 11 theorems we discussed in this chapter, Nana. Okay, especially the theorems all are there for the properties of the parallelogram. Properties of a parallelogram, children. And I want to discuss a few more properties also. For square, in a square, diagonals are bisect at right angles and equal, children. In a square, diagonals are bisect at right angles and equal. In a rectangle, diagonals are equal and bisect each other, not at right angles. Under rhombus, diagonals are bisect at right angles but not equal, children. See here, whatever the properties are there for the rhombus, that all are there for there for the square. Whatever the properties are there for the rectangle, that all are there for the square, Nana. These all we will discuss in the exercise problems, Nana. Okay, na? Whatever the remaining properties are there, that all we discussed in the exercise problems, children. Is clear? In this chapter, first we learn what is the quadrilateral, what is the angle sum property of a quadrilateral, and what are the types of the quadrilateral, and properties of the parallelogram. In this properties of the parallelogram, we discussed 9 properties, theorems, and next one is midpoint theorem and converse of midpoint theorem, children. Is clear? Thank you, children.